Adamantium, Vibranium. Fictional metals forged in comic books and superhero movies, imagined with scientific precision. But is it possible for these two super metals to be developed? Can they become reality? The idea of their existence has long fascinated scientists, comic book fans, and futurists alike. These fantastical substances were born from the fictional world of Marvel Comics. They represent materials that defy our current knowledge and understanding of matter. Vibranium is a powerful metal that also absorbs and redirects kinetic energy. It's a super metal made famous by Captain America and his vibranium shield, while adamantium is virtually indestructible. This super metal makes Wolverine an indestructible machine with his adamantium-coated skeletal structure and claws. But could anything like these super materials actually exist somewhere in the universe? Could it be possible that the periodic table as we know it is incomplete in ways that could make these imaginary metals a physical reality, or perhaps something close to it? And if not through conventional chemistry, could quantum physics offer the key to understanding or even creating such materials? To begin, we must accept a fundamental truth. The known elements in the universe are limited. As far as terrestrial science is concerned, we've catalogued all the naturally occurring elements and even synthesized a few unstable ones beyond uranium. These synthetic elements, like oganesson or fluorovium, last for fractions of a second before decaying. They're not practical for crafting anything, much less an energy-absorbing super shield or indestructible sword or skeletal structure. But our universe is vast. Billions of galaxies, each with hundreds of billions of stars and even more planets. The diversity of physical conditions across the cosmos could theoretically allow for atomic arrangements and molecular structures we've never seen or even imagined. Planets with much higher gravity, unusual atmospheric compositions, or entirely different pressures and temperatures could foster chemical interactions that produce stable compounds that are unknown to humanity. But the problem is, the added behavior of vibranium goes far beyond anything theorized, known, or imagined by the scientific community. Its core feature, absorbing and redistributing kinetic energy, would require a material that somehow stores mechanical energy without deforming or heating up significantly. In materials science, we have some precedents for this, though on a vastly smaller scale. Non-Newtonian fluids, for example, change viscosity under pressure, and piezoelectric materials generate electric charge under mechanical stress. But these properties are minor compared to what vibranium can do in the fictional world of Marvel. Is it possible that there exists a material with a structure that is purpose-built down to the tiniest particles that could guide and store energy in a highly controlled way using the strange rules of quantum physics? In theory, a quantum material, which is a substance whose properties are governed by quantum mechanical effects on a macroscopic level, could act in a way that mimics vibranium. We are only beginning to understand materials which behave in non-classical ways and have exotic properties tied to the quantum world. Maybe a material with highly ordered entangled electrons could store energy in a form of quantum potential, releasing it only under specific conditions. Adamantium, on the other hand, is about sheer durability and tensile strength. It can withstand virtually any kind of physical force without breaking, bending, or even being damaged. In the real world, materials like graphene and carbon nanotubes exhibit extraordinary strength-to-weight ratios that vastly outperform steel. These materials derive their power from atomic-scale bonding. The carbon atoms in graphene are arranged in a hexagonal lattice so strong it would take an elephant balanced on a pencil to break through a sheet the thickness of saran wrap. But graphene is not indestructible. It burns, it tears under certain conditions, and it can't stop a speeding bullet. We need to imagine a real-world material where not only the atomic bonds are stronger, but where the atoms themselves are something entirely new. Perhaps heavier isotopes or even exotic particles that form under high-energy conditions, such as those in the cores of neutron stars. If there's a place in the universe where adamantium-like materials could exist, it would most likely be in extreme environments. The collapsed cores of massive stars, known as neutron stars, are so dense that a teaspoon of their matter would weigh billions of tons. The outer crust of a neutron star is believed to contain nuclear pasta, a form of matter so dense and rigid that it may be the strongest substance in the known universe. It is composed of atomic nuclei packed so closely together by gravity that they form strange spaghetti-like shapes, hence the name. This material would withstand force and physical damage better than anything known on Earth. But it's obviously not something we can extract and forge into hand blades or functional armor. The neutron star material would explode instantly, as it requires the immense gravity of a neutron star for it to possess its properties. Still, it hints at the possibility that nature has already invented substances that go far beyond anything we can currently synthesize in a lab. Another frontier in this search lies in the realm of quantum field theory and particle physics. Could certain materials gain unique properties through the manipulation of quantum fields or vacuum states? Some speculative theories in physics propose the existence of exotic matter, which would have negative mass or energy. If exotic matter exists, it could potentially alter the fabric of space-time or interact with ordinary matter in ways that drastically change its physical properties. Is it possible that a metal alloy infused with or stabilized by exotic matter might behave in a way that mirrors the impossible capabilities of adamantium or vibranium? We need to consider whether such materials are even chemically plausible. On Earth, chemical bonds and atomic interactions follow well-understood rules based on the periodic table. But new elements and new forms of bonding could emerge if the laws of physics are bent or extended under extreme or unique cosmic circumstances. Silicon and carbon are both capable of forming complex molecules, but carbon is more versatile due to its ability to form 4 strong covalent bonds. Could there be another element, one we've never seen, with bonding properties even more complex and resilient than carbon's? If so, it might allow for the creation of self-healing, energy-absorbing, nearly indestructible materials. However, it could easily be argued that the possibility of such materials existing is most likely the product of overly optimistic speculation. Even if such materials don't exist naturally, it may be possible one day to build them from the ground up using nanotechnology. The idea would be to construct materials atom by atom, tailoring the structure at a molecular or even quantum level to produce properties that defy traditional limits. Quantum computing already requires materials that maintain coherence among quantum bits, something that ordinary matter can't do. As we learn to manipulate matter with greater precision, we may invent new states of matter, alloys or hybrid materials that behave like adamantium or vibranium, not because they exist in nature, but because we made them that way. So, is it possible that vibranium or adamantium exists somewhere in our universe? Probably not by those names, and most likely not exactly as Marvel Comics describes them, but materials that approach their mythic qualities, indestructibility, energy absorption, extreme strength, may already exist under alien conditions or could be created with future technologies and science. Quantum physics, nanotechnology, and the study of exotic matter may eventually give rise to something functionally equivalent. What's fiction today may just be the blueprint for our dreams and imaginations to become reality sometime into the future.